Today is day 1 on geometric series. For the warm-up, list each sequence, which is a list of numbers, ordered list of numbers, as arithmetic or geometric and find the common difference or the common ratio. So remember, if you get a list of terms and you're unsure, you can take one term and subtract by the term before it, and if that works every time, that's a common difference. And if that doesn't work, you can try to see if it's geometric by taking one term and dividing by the term before it to find a common ratio. Most of you are able to just look at the pattern and figure it out, though. This one right here, it alternates, so I know it must be multiplying, and it's being multiplied by a -3. So here, there's a common ratio, and that common ratio is -3. So we're going to multiply by -3. The second one, it looks like we're adding. We're adding 2 every time, so that would be a common difference. It's arithmetic if you're adding or subtracting, and that common difference is +2. So that's review from chapter 1 where we looked at arithmetic and geometric sequences and their common difference and common ratios. So to review, a sequence is an ordered list of numbers. And in chapter 9, and this is why we put them together, we're going to look at sequences, but we're going to add them up. So a series is a sum, a specified sum of a sequence. Specified. So I might say add up the first 10 terms or add up all the terms. So specified sum means we add them up of a sequence. So in chapter 1, we look at sequences, the ordered list of numbers, and now chapter 9, we look at adding up a specified sum of a sequence. So we're going to spend a few days looking at how to find a series, a sum of a sequence. To find the sum of an arithmetic series, you can use an equation. And that equation we looked at yesterday when we looked at Gauss's video of his childhood and how he added them up. To find the sum of any number of terms, we take the first term plus the last term, and we multiply it by how many terms there are, and then we're divided in half. So we looked at Gauss yesterday, how he added up the numbers 1 through 100 really quickly by writing them out 1 through 100, reversing them, and then finding a pattern, dividing by 2. Okay, so this is the formula that we looked at yesterday to find the sum of an arithmetic series. Today, though, we're going to look at a different type of series and how you find the sum of that. So here's our problem of the day. Let's say Lou baked an apple pie and he promptly ate half of it as soon as it was done. Determined to make the pie last, he then decided to eat only 1/2 of that pie that remained each day. So let's fill out this table. Record the amount of pie that Lou eats each day for the first 7 days and the total amount of pie eaten since it was baked. All right, so here we have day 1, day 2, day 3, day 4, day 5, day 6, and the amount eaten. So the first day he has a whole pie, he eats half, so total he's eaten half the pie. The second day he has to eat half of the pie left, so he eats 1/4 of the pie. And so we're going to add 1/4 plus 1/2, and that will give us 3/4. All right, so there is 1/4 of the pie remaining, and he eats half of the 1/4. So if we do half of 1/4, that equals 1/8. So he eats 1/8 of the pie. And then if we add 1/8 plus 3/4, we get 7/8. Okay, and then the next day there's 1/8 of the pie left and we eat half of 1/8. So 1/8 times 1/2 is 1/16. So you can see that we're multiplying each of these by half. We add these together, 7/8 plus 1/16. And how we're adding the fractions, you get a common denominator, so I'll add this one up over here. 1/16 plus 7/8 is the same as, we can multiply each of these by 2. So it's the same as 14/16. So this is 15/16. All right, and then the next day we have 1/16 of the pie, we eat half of that, so multiply by half, we get 1/32, and the next day we multiply that by half, we get 1/64. Take a look at this list. This is 1/2, this is 3/4, this is 7/8, 15/16. Can you guess what the pattern is? Well, if you take a look at this, 1 plus 2 is 3, and it's 3/4. 3 plus 4 is 7, 7/8. 7 plus 8 is 15, 15/16. So 15 plus 16 is 32, so this will be 32/33, and 32 plus 33 is 65. Oh wait, no, we're doing this wrong, sorry, the pattern's different. you look at the pattern, the denominator remains the same here. So this is half, half. This is 4 on the bottom of 3 over 4. So this is over an 8, 7 over 8. This is 15 over 16. So this will be 31 over 32 if you follow the pattern. Or we could just add 1/32 plus 15 over 16, 31 over 32. This one will be 63 over 64. All right, if you calculate the 63 out of 64ths of the pie, he's eaten almost that whole pie. But still, there's a little bit left that we can cut in half to eat. So the question is, if Lou lives forever, about how much of this pie will he eat? He's going to eat about the whole pie. There'll be crumbs left that he can still cut in half, but he's going to eat about the whole pie. The one whole pie, I should say. Okay, so let's take a look at vocabulary. This is a geometric sequence. A geometric sequence has a common ratio, and so if you add them together, it's called a geometric series. So it's the specified sum of a geometric sequence. The infinite geometric series formula can be used only if your ratio, the absolute value of the ratio, so the positive value of the ratio, is less than 1. And if it's less than 1, what's happening is your values are decreasing. These values are decreasing right here. So you can add them together, and they will add up to a sum. It won't keep going on forever. Since things are getting smaller and smaller, you can add it up to one thing. So if it's an infinite geometric series, we can add everything up and get one sum. Here's the formula. The sum is the first term over 1 minus the ratio. So again, R is your ratio. U sub 1 is first term. All right, let's do that for the pi problem. What's the first term in the pi problem? Well, if we look, the first term in the pi problem is right here. This is our list of numbers, 1/2, 1/4, and so on. And the first day we eat half of the pie. All right, so our sum will be half over 1 minus the ratio. Well, what's the ratio? What are we multiplying by each time? We're multiplying by 1/4, or 1/2. And if you didn't know that, you would take 1/4 divided by 1/2, you get half, and so on. So we're multiplying by 1/2 each day. So there's our ratio. Okay, so if you divide this out, this is half divided by half, which is 1. So the sum of all these numbers right here, if we add all of these numbers up right here, it will equal 1 whole pi. So that's how we define the sum of an infinite geometric series. Okay, how can you tell if the series is geometric and infinite? First step, check and see if the common ratio, the absolute value of that, is less than 1. So before it was 1/2, so we knew it was a common ratio less than 1. And you can also look at the summation notation. So here's the summation notation saying add up all the terms from the first term to infinity of this geometric sequence. We know it's geometric because of this exponent here. Geometric is exponential. Here's the first term, u sub 1. Here's your ratio, 0.1. The reason why it's n minus 1 instead of n is because we're starting at the first term, not the 0 term. So we do have to take that into account and put this n minus 1. Okay, so if this is 1 right here, this will be n minus 1. All right, so let's take a look at this, and let's find the sum of this series. So the sum is the first term over 1 minus the ratio. The first term is 0.3. The ratio is 0.1. So we can calculate if we were to add up all these terms in the sequence, they would add up to one number because they're decreasing. So 0.3 divided by, what is that, 0.9? So it's about 1/3. So all these numbers would add up to 0.3, repeating are 1/3. Let's do another example. Write a geometric series in summation notation and find the sum. So we're going to take this and convert it to this right here. Okay, so to do that, we're going to say, we're going to call this our first term right here. So n equals 1 to infinity. First term is 36. What's the ratio? Take any number, divide by the number before. It looks like half. And since we started the first term, we need this to be n minus 1 so that we get it to be the correct term. All right, let's find the sum. We can do that because our ratio is less than 1. So since these are decreasing, it will eventually go down to 0, and we can add these up to get one sum. The sum is the first term over 1 minus the ratio. And so here, that will equal 72. Okay, so if we add these all together, that should equal 72. Okay, how do we use this formula to change a repeating decimal to a fraction? Okay, so here, if I split this into a sequence, the first term would be 0.4. The next term would be 0.04. And if I add these up, I would get this right here. The next term would be 0.004. And if I add these all up, I get this repeating decimal. Okay, so here's our first term. Let's figure out the ratio. To find the ratio, we take any number, divide by the one before it. And so we get 0.1. All right, so this could be an infinite geometric sequence. We know that because the ratio is less than 1. So we have our first term divided by 1 minus the ratio. We get 0.4 over 0.9. If I multiply each of these by 10, I get my repeating fraction. 4 divided by 9, 4/9. If you divide that, you get 0.4 repeating. Let's try that again. Again, I'm going to write this as a sequence. The first term of my sequence would be 0.18. The second term would be 0.00018. The next term would be 0.000018, and so on. So here, our first term is 0.18. The ratio, we take any number, divide by the number before it. Oops. And so our ratio here is 0.01. To find the sum, we take our first term, divide by 1 minus the ratio. So that's 0.18 divided by 0.99. And we can reduce that fraction to 2 over 11. So again, this becomes 18 over 99, and then divide each by 9, and you get 2 over 11. And try in your calculator. 2 divided by 11 is 0.18 repeating. So we learned a couple things this lesson, how we change repeating decimal to a fraction using our sum formula. And we also looked at summation notation, which has our starting value or rate of change to the n minus 1 power with the summation. It means add them all up from the first term to infinity.